mitochondria, and in the center of the cell we have the nucleus with chromatin. After 2 irradiations, the picture has changed. Let me just nip back to that this one here, because the interesting thing is the double staining with this oolong tea extract for vimentin. Vimentin is an enzyme which is one of the building blocks of collagen. Vimentin copolymerizes with desmin to make collagen. And all these little black dots, these are vimentin granules. But in granules, they're no use. They need to be in fiber format, vimentin fibrils. And when we look at the picture 48 hours after 2 irradiations, you can see that a lot of these vimentin granules have become vimentin fibrils. You can see that there are many, many more mitochondria. And you can also see that the chromatin in the nucleus is locating at the membrane, which means that this cell is ready for some signaling. It knows something is going to happen. And then when we look again, 48 hours after 4 irradiations, look at the number of mitochondria. Look at the color of the mitochondria. They're dark, they're electrodense. This means that they're pumping out ATP like nobody's business. And the mass of fibrils inside the cytoplasm tells us that this cell is fibroplasic. It's getting ready to make collagen. Now, collagen is not made overnight, unlike the claims of some other systems. It takes 7 days before collagen starts to appear from a cell. But in this case, it's cut down to 4 days, 3 or 4 days. So it halves the time in which collagen is produced by irradiating the cell with 633, and we've just recently had the same data with 830. Tons and tons of mitochondria. And then we come to remodeling, and our friend 830 produces fibroblast to myofibroblast transformation very, very efficiently compared with the other wavelengths. And when we look at all skin cells, particularly keratinocytes, once again, keratinocytes are the mother keratinocytes, the stem cells in the epidermis. And if we always remember to keep them happy, then we will always have happy customers, because with activated keratinocytes, we get a very healthy epidermis. But we also get cytokines dropping down into the dermis. And this is important for one of the stages of treatment with the Healite. Any questions about skin cells and wavelength? I have bamboozled everybody. That's what I like.
How long did you actually irradiate the skin for?
It was in the red LED, it was 20 minutes to give 126 joules per square centimeter. Okay. And in the case of the infrared, it was 60 joules per square centimeter, and that was 11 minutes. If it's the Omnilux, it's 20 minutes to produce the same dose at 830 nanometers. Yes, yes. Yes.
Could you comment on skin colour, because you've obviously done it on a Japanese population?
Yes. With the 830 nanometer wavelength, because melanin is not such a problem, it is very much colorblind. I mean, we've treated type 6 with the 830. With red, there is a little bit higher absorption in melanin, so a little bit of the energy is stopped in the epidermal melanin and doesn't penetrate. But because the energy is so low, it doesn't heat up the skin. It just means that you've got to give a few more treatments in order to give the same effect in the dermis with the darker skin types.
The infrared light that you're talking about, is that very similar to your heat lamps?
It's similar, but it's a different wavelength. Okay. The heat lamp is much longer. It's a much longer wavelength, so it creates heat through juggling the tissue around in a photophysical reaction. In fact, if you look at FDA clearances, you will see that the original clearance for laser therapy was against a heat lamp, although they're completely different in their action in the tissue. So the heat lamp is very super, you know,
Let's say, for example, you have, in your case, you're talking about a patient not just for skin rejuve, but let's say you're talking about a patient that has a torn hamstring muscle.
right.
Okay.
Okay.
So at that depth, you're going to get some wound response.
You're going to get, I mean, the hamstring, the Achilles.
Why I'm asking, my daughter's actually got a hamstring tendon.
Well, treat her with 830. It penetrates. I mean,
I'm just going to text her now.
you look at this red. Look at this red light. You know, I mean, and 830 penetrates much better than red. It goes centimeters into tissue.
So on that line, you showed the bottom of the peak of absorption. So that's actually not being absorbed. So that's why it's penetrating so deep. So you're saying the mast cells selectively do pick up that wavelength, and most other tissue doesn't?
Mast cells, macrophages, and neutrophils all share a certain component in their membrane that is the prime chromophore for 830. Not 800, not 900, but 830. The mitochondrial DNA is secondarily activated because the 830 doesn't go through the membrane. And it's secondarily activated by the necessity of the cell to produce more energy. In the case of the red light and the yellow light in vitro, you find that's the prime activator is mitochondrial DNA through cytochrome C oxidase. This 830, there was one paper published by Baxter and colleagues from the University of Ulster a couple of years ago, and it was a sports clinic, a professional sports clinic, and it was a mixture of acute and chronic, 29 patients, and of the 29, all of the acute patients felt tremendous relief from their pain. That was a variety of strains, sprains, ligaments, etc., etc. And of the chronic, only 2 didn't respond. So it's a very effective wavelength for deep-seated sports-related injuries. And therefore it's very good for everybody. Okay, goody goody. So, what makes our Healite II such a new concept in phototherapy? I'm sure many of you are familiar with Omnilux. I worked with phototherapeutics from 2002 till 2009 and helped the development of the Omnilux. And I think the Omnilux is a fantastic system. But you have to go forward. And I think that's what the big difference is between Healite and Omnilux, apart from the price difference, which is also quite important. And you can talk to Catherine and her merry men and women about that later. So, the first thing is intensity. We have upped the intensity of the system. If we take a single LED and light it, we won't get very much, but we will get something. It doesn't matter how little light penetrates tissue, you do get benefit from sunlight. There is cellular activity activated by sunlight. That's why people with psoriasis and eczema go to a sunny climate and give themselves some heliotherapy. That's very, very, very low level. We're talking microwatts per square centimeter, not milliwatts, but microwatts per square centimeter. But then when we take LEDs and we put them beside each other so that the beams intersect, we get this wonderful thing called the photon interference phenomenon, when the photons collide and drive each other forward. And when you see all of the LEDs lit up, you can see that there is a very interesting high intensity area beneath the surface of the skin, because red light and especially infrared light scatter like nobody's business. So you have photons going forwards, backwards, back out the skin. And this area here is where the highest intensity is. One of the first lasers that was used in surgery was the neodymium YAG in continuous wave, and it's at 1064, 1064, so near infrared. And the big problem with people who didn't know the characteristics of scattering was they would put it on tissue and they'd go, no effect, give me another 10 watts, Gene. So Gene gives them another 10 watts. No effect, give me another 15 watts, Gene. And suddenly there's this bloody great hole in the skin because the heat was actually happening under the surface of the skin. And this is good for this system and also Omnilux, obviously, because you want to be in the dermis. And you're still going through the epidermis to get to the dermis, so you're still activating the epidermal cells. So what we did was we took what we call optical lens array technology. And this consists very simply of a semi-collimating lens under every single LED in the treatment head. And what these semi-collimating lenses is, they narrow the beam. So if you have X photons in a beam this size and X photons in a beam this size, this is obviously much more intense. We have increased the photon intensity, and that gives us an even higher photon intensity deep in the tissue. The other thing we did was called photo sequencing, and this is proprietary, and it's now covered by patents, and there are other patents pending. So what is involved here is if we look at one of these panels and we cut it across, you'll find there are 12 LEDs in the cross section, and 3 LEDs in. We actually have a double wavelength LED, a double chip LED, which produces 590 nanometers yellow. Now you remember from penetration in human skin, 590 doesn't penetrate very well, but we don't want it to penetrate well. We want it to activate the keratinocytes and the Merkel cells in the epidermis. So what happens is, for 1 minute, when you turn the system on, you get yellow light only. Only the 590s, 2 rows per panel, scan across the tissue. Very superficial epidermal targets. And after 12 of these cycles, the 830 nanometer LEDs cut in with a fluence of 60 joules per square centimeter. The 590 LEDs continue. Now, one of the major problems with invisible infrared is that your clients or patients can't see it. And if they can't see it, they don't believe it. The yellow keeps on going. Now, any clinical application of the yellow is washed out by the many orders of magnitude superior power, but your clients and patients will still see it, so they know something is happening. And in fact, FDA gave us our FDA clearance for Healite with this yellow light as the aiming beam. So it has both a scientific and a psychosomatic application. And jumping back to OLAT, this slide should have been before the last lot. This is an 830 panel. This is the target. You can see there's a lot of side scattering. It's taken with an infrared camera. And this is what the optical lens array technology sheet looks like. It's just an optically designed plastic sheet with all these little semi-collimation lenses, and that's popped over the LEDs. So it's 2 functions. It works to increase the intensity, and it also protects the LEDs, because if this gets scratched, it's a 5-minute changeover job. And when we look with the OLAT, you can see it's a completely different picture. The output is the same. This is the same as this, but when you look here and when you look here, you can see that much more is directed forwards. So we are optimizing the photon intensity. All right, any questions about photosequencing or optical lens array technology? Let me say the photosequencing only happens with the 830. It doesn't happen with the 633 or the 415 head. Why? Because they're visible. And we would then be creating a problem for the cells, because we would be giving them 2 sets of visible information. And one set might be saying, turn right, and the other set might be saying, turn left. So the cell goes turn right, turn left, give up, and not do anything. And there are some excellent studies from Professor Tina Carew, who's the world's leading photobiologist from Russia, and she has shown that not only do some wavelengths cancel each other out, some wavelengths, when combined, retard tissue. So we have to be very careful when we mix colors on skin. Single wavelength at a time is the order of the day, unless we know that they are different targets, right? Because 830 is epidermal, and so 830 is epidermal, dermal and below, and 590 is only epidermal and very, very weak. Yes?
Say that, are there units out there that do multiple colours at multiple times?
Call it an expensive Christmas tree. Now the big problem is when you think of some of these colours, anything up to orange doesn't go through the epidermis. Right? It doesn't do anything. Green light does not go through the epidermis. Green light is stopped in melanin. So what are you treating? Unless your patient has got dyschromia, which you might argue can be treated with green light, and there are some papers in the literature that show incipient nevus spilus or something like that is treated very successfully with green light. LLLT, not surgical. But otherwise, when you mix up these wavelengths, you are really confusing the living daylights out of the cells. And in some case, you're stopping them.
Yeah, I can imagine if they were all together, it's like...
Right, but even if they flash on and off, what you're doing then is you're saying to the cell, turn right. Okay, so the cell has turned right, and it started to go right. And suddenly the next light comes and says, no, turn left. So the cell goes, all right, I'll turn left. You know. So you're still confusing the cells, but you know, sequentially.
Like, like purple and blue and green and
yes,
like that.
Yes.
Oh.
Well, there is no such thing as purple. There is no such thing as purple light. There's blue and red, and when people mix blue and red light, they call it purple, or when they mix yellow and red, they call it orange. But the skin cells see red and yellow, or blue and red, because that's the physical value of color. And multicolor, there's a confusion here between phototherapy and chromotherapy. Chromotherapy is established. It's the use of multiple colors to influence chakra, right? So you're doing the heart chakra or the lung chakra or whatever, and that's chromotherapy, which is a little bit different from phototherapy. There are studies which show continuous wave will improve cell regeneration more efficiently than a whole series of different frequencies. The study, the one I'm thinking of was from Brazil.